Okay, get ready, because today we're going to jump into wormholes.
Oh,
You know,
yeah.
those theoretical tunnels through space-time,
Yeah.
the ones that could connect distant corners
Yeah.
of the universe like some kind of cosmic shortcut.
Right.
It's like something straight out of science fiction.
It really is.
But the really wild part is that it's based on real physics.
Absolutely. Wormholes come from Einstein's theory of general relativity,
Oh, wow.
which has been incredibly successful in explaining gravity and the large-scale structure of the
I
universe.
see.
So even though they might seem like pure fantasy, there's real science behind exploring these.
That's so cool. So we're not just messing around with theories.
Nope.
There's real science behind this wild idea.
Definitely.
Welcome to Cosmos in a Pod, Space and Astronomy
Glad
series.
to be here.
Now, let's break this down a little. For
Okay.
those of us who aren't astrophysicists,
Right.
could you explain what a wormhole actually is?
Sure. Imagine space-time is like a big flexible sheet, like a giant trampoline. If you put a bowling ball on that sheet, it makes a dip, right?
Yeah.
That's basically gravity warping space-time.
I got it.
Now, a wormhole is like folding that sheet so two distant points touch. It creates a shortcut, a tunnel, through space-time itself,
Wow.
connecting those points directly.
Okay, I'm starting to picture this.
Good.
So instead of traveling the huge distance across the sheet,
Right.
you could theoretically take a shortcut through this tunnel.
Exactly.
That's
It
crazy.
is pretty wild.
So these tunnels,
Yeah.
they have an entrance and an exit, right?
That's the general idea.
Like a cosmic subway.
Uh-huh.
Kinda.
A wormhole is envisioned as having two mouths connected by a throat.
Yep.
You go in one mouth
Right.
and theoretically come out almost instantly from the other,
Yeah.
potentially light years away.
That's amazing, isn't it?
That's mind-blowing. But wouldn't traveling through this tunnel be a bit, well, crushing?
That's a great question.
I mean, we're talking about bending space-time itself. Right, and that brings us to the idea of traversable wormhole,
Traversable.
meaning something could actually travel through it safely.
Oh,
It
yeah.
would need to be stable and open.
I see.
And for that, you'd need something called exotic matter.
Exotic matter. Now, it really sounds like we're in science fiction territory.
Uh-huh, I know, right?
What is this exotic matter?
Well,
And how does it work?
it's a hypothetical type of matter
Okay.
that has negative energy density.
Negative energy.
Yeah, it's like anti-gravity.
Whoa.
It would work against the intense gravity that would try to collapse the wormhole,
I see.
keeping it open and stable for things to pass through.
So this exotic matter is like scaffolding, holding the wormhole open.
That's a good way to think about it.
But you said exotic matter is hypothetical.
Yes.
Meaning we've never actually seen it.
That's right.
It's still just a theory.
Exactly.
And that's one of the biggest challenges with traversable wormholes, I guess.
It is.
So even if the math of wormholes works out, actually finding or creating one we could travel through is a whole other story.
A much bigger challenge, for sure.
Wow, this is a lot to take in.
I know, it's pretty mind-bending.
Theoretical tunnels,
Yes.
exotic matter that we've never even seen.
Right.
Feels like we're dealing with a lot of what-ifs here.
That's true, but even exploring these what-ifs can be really valuable.
How so?
It pushes the boundaries of our understanding of science and opens up new avenues of research.
I can see that. I'm all for pushing boundaries.
Me too.
So let's say, just for fun, that traversable wormholes do exist.
Okay.
What can we actually do with them?
Well, imagine interstellar travel.
Yeah.
Without being limited by the speed of light. We could potentially zip across the universe,
That's amazing.
exploring distant galaxies and star systems that would normally be impossible to reach.
Now you're talking. That's the kind of science fiction dream that I love.
Aha, I know, right?
But wait, are we talking about time travel too?
Well, time travel is a potential consequence of wormhole theory.
Brea.
If one mouth of a wormhole were to move at relativistic speeds
Okay.
or experience really different gravity,
Yeah.
time dilation could happen,
Time dilation.
meaning time would pass differently at each end of the wormhole,
Oh, well.
potentially allowing travel to the past or future.
Hold on.
Okay.
So you're saying that going through one of these wormholes could be like stepping into a time machine.
Theoretically, yes.
We could actually travel to the past or future.
But it's important to remember that this is all based on highly speculative physics.
Right.
There are a lot of unknowns
Sure.
and potential paradoxes to think about,
Paradoxes. Like what?
like the grandfather paradox.
Hey.
What's that?
If you traveled back in time and accidentally killed your own grandfather,
Okay.
you would create a paradox
How so?
because you couldn't exist without him.
Oh, I see.
It's a thought experiment that highlights the potential problems of time travel.
That's definitely a head-scratcher.
It is.
So, while the idea of time travel through wormholes is really interesting,
Yeah,
it also comes with some serious theoretical baggage.
definitely.
Maybe we should leave that alone for now.
Probably a good idea.
We've covered a lot: theoretical tunnels, exotic matter,
Uh-huh.
interstellar travel, even time travel.
That's a lot.
But let's get back to reality for a second.
Okay.
Is there any reason to believe that wormholes actually exist?
That's the big question, isn't it?
Or are we just playing around with theoretical physics?
As of right now, we have no direct evidence of wormholes. But remember, they do fit with Einstein's theory of general relativity,
Yeah,
which has passed every test we've thrown at it so far.
that's true.
So we can't rule them out.
So it's not impossible.
Not at all.
This is all so fascinating.
It is.
Theoretical objects that could completely change space travel.
Absolutely.
Maybe even time travel.
Right.
Makes you wonder what else the universe is hiding.
You know, it really does.
What I find amazing is that these ideas that seem so crazy
Right.
could actually have roots in real physics.
Absolutely.
It makes you question what we really understand about the universe.
It really does.
It's a testament to human curiosity and our desire to understand the cosmos.
And our place in it.
And it makes this deep dive even more exciting.
I agree.
We've laid the groundwork,
Yes.
explored the theoretical side of wormholes,
Uh-huh.
and dipped our toes into the possibilities they present.
Right.
But I have a feeling this is just the beginning.
Oh, definitely.
Let's take a moment to think about everything we've talked about.
Okay.
And when we come back,
Yeah.
we'll delve even deeper into the world of wormholes,
Sounds good.
exploring the latest research,
Right.
the challenges scientists face,
Okay.
and what this means for the future of space exploration.
I'm looking forward to it. Welcome back to Cosmos in a Pod.
Before the break, we were talking about wormholes.
Those theoretical tunnels through space-time.
Yeah, and I was still trying to wrap my head around that exotic matter stuff.
It's a wild concept, isn't it?
It really is like something out of science fiction.
It is pretty far out there.
The idea that we might need this weird, hypothetical substance to hold a wormhole open.
Yeah, it's exciting and challenging at the same time.
It really pushes the limits of what we know about physics.
Absolutely.
You mentioned that exploring these what-ifs can be really valuable.
Yes.
Can you explain why?
Well, even if we never actually find a traversable wormhole,
Right.
just studying them can lead to new discoveries and advancements in other areas of physics.
Like a ripple effect.
Exactly.
So it's not just about the wormhole itself.
Right.
It's about the journey of discovery.
And the new knowledge we gain along the way.
I see what you mean.
For example, look at the research on wormholes and black holes.
Oh, interesting.
There's some thought that the singularity at the center of a black hole
Yeah.
could actually be a type of wormhole,
Whoa, really?
connecting to another point in space-time,
Wow.
maybe even another universe.
Another universe? That's incredible.
I know, right?
But how could we ever study something like that?
That's the challenge, isn't it?
We can't even see inside a black hole.
True, but scientists are using computer simulations.
Simulations.
Yes, sophisticated ones that can model the extreme conditions inside black holes.
So we can't directly observe these things,
Not yet.
but we can use simulations to test theories
Exactly.
and gain a deeper understanding.
That's right.
It sounds like there's a lot of exciting research going on,
Oh, definitely.
even if we're not building wormhole spaceships just yet.
Uh-huh. Not quite.
Another area of research you mentioned is quantum wormholes.
Yes, fascinating stuff.
Remember when we talked about quantum entanglement,
Of course, that spooky action at a distance.
where two particles are linked no matter how far apart they are?
Exact.
Measuring one instantly affects the other.
It's still mind-boggling to me.
Me too. It gives me chills.
But here's the really interesting part.
What's that?
Some physicists think there might be a link between entanglement and wormhole.
Wait, you're saying that two entangled particles
Yeah.
might actually be connected by a tiny wormhole?
That's the idea behind the EPR conjecture.
Go what?
It's a very speculative theory,
I
but it's generating a lot of interest in the physics world.
can imagine.
It suggests that these tiny quantum wormholes might be woven into the fabric of reality,
Wow.
playing a fundamental role in how the universe works.
That's incredible. So we haven't found any giant wormholes.
Right.
But the search continues on a much smaller scale.
Exactly.
Studying these quantum wormholes could lead to breakthroughs
Absolutely.
in our understanding of quantum mechanics, gravity, and spacetime.
It's a really exciting area of research.
It's amazing to think that something so small could have such huge implications.
I agree.
But let's talk about the practical side for a moment.
Okay.
Even if we could create a traversable wormhole,
Uh-huh.
wouldn't the energy needed be astronomical?
You're absolutely right.
Yeah. I mean, the amount of exotic matter
Yes.
with its negative energy density,
Right.
it would be immense, far beyond what we can even imagine producing right now.
It would be a huge challenge, to say the least.
So even if the physics works,
Yeah.
the engineering challenges are basically impossible for now.
It seems that way.
But scientific progress can be unpredictable.
That's true.
What seems impossible today might be commonplace tomorrow. Like 100 years ago, going to the moon seemed like a fantasy.
Right.
And now we're talking about warping space-time and traveling to other galaxies.
It's amazing how far we've come.
It really shows human ingenuity and curiosity.
I agree.
Today's physicists are pushing the limits of our understanding,
Just like the early space pioneers.
exploring ideas that might seem crazy but are based on real science.
It's an exciting time for physics.
This deep dive has been incredible.
It has been fascinating.
You've explored the mind-bending world of wormholes,
Absolutely.
discussed the latest research,
And the challenges ahead.
and even touched on the implications of time travel and alternate universes.
It's been a great discussion.
But before we wrap things up,
Yeah.
I'd love to hear your thoughts on what all of this means
Okay.
for the future of humanity and space exploration. Wow, this deep dive into wormholes has been a wild ride.
It really has.
From the mind-bending theory to those crazy possibilities.
And the massive challenges.
This really made me think,
It's definitely stretched our imaginations.
even if we never build a spaceship powered by a wormhole,
Right.
the things we learn from studying these theoretical objects
Yeah.
could change science and technology in ways we can't even imagine.
Absolutely. Just think about the advancements in computing,
Oh, yeah.
energy production, or even material science.
Wow.
All because we're trying to understand and manipulate exotic matter.
It's like reaching for the stars and finding new tools and technologies along the way.
That's a great way to put it.
And those tools end up changing life here on Earth.
Exactly. The search for knowledge often leads to breakthroughs.
That benefit everyone.
It's so many ways.
And it's that drive to explore and discover
the curiosity.
that keeps pushing us forward.
It's what makes us human.
Even if we never find a real wormhole,
Yeah.
just thinking about these concepts,
And exploring the possibilities.
it helps us understand the universe.
Our place in it.
It's like seeing a distant galaxy through a telescope for the first time.
I know that feeling.
It makes you realize just how vast and mysterious the universe truly is.
And how much more there is to discover.
That sense of wonder is what drives science.
It inspires us to keep searching for answers.
This deep dive has been a perfect example of that.
We've covered so much.
We've explored the crazy science of wormholes
The latest research.
and even the implications of time travel.
And alternate universes.
It's been an amazing journey,
It really has.
and it's only the beginning.
As we continue to explore the universe.
Who knows what other amazing discoveries are waiting for us?
I can't wait to find out.
I bet our listeners are excited to continue the journey too.
I hope so.
For those who want to learn more about wormholes,
There are so many resources available.
you can find tons of information online and in libraries.
It's a fascinating topic.
And don't forget to subscribe to Cosmos in a Pod.
For more deep dives into the universe.
We're always exploring new topics.
And bringing you the latest scientific findings.
You can also check out our YouTube channel for even more great space content.
We have stunning visuals and expert interviews.
So as we wrap up this cosmic adventure,
It's been a pleasure.
I want to leave you with one last thought.
Okay.
If wormholes really do exist,
Yeah.
what might be on the other side?
Another galaxy.
A different dimension.
Or something we can't even imagine.
The possibilities are endless.
And that's what makes it so exciting.
The universe is full of mysteries waiting to be uncovered.
You'll keep looking up.
Keep asking questions.
And never stop exploring.
From all of us here at Cosmos in a Pod.
Keep those imaginations running wild.
And your minds open to the wonders of the cosmos.
Until next time.
Happy exploring.